How are you, dear families of my channel? Welcome to this exercise class. This is exercise 1.5, and the first question, number one, A is calculate the oxidation state or oxidation number of iron in potassium ferrocyanide compound. This is complex compound. Okay, this is potassium is group 1 a metal, and all are having +1 oxidation state, therefore it is assigned as +1. And iron is unknown, is symbolized by X to be calculated, and cyanide ion having the radical -1, because in cyanide ion carbon will form positive 4 oxidation states and nitrogen -5 oxidation states. The summation of 4 and -5 becomes -1, and there is a subscript multiply -1. Therefore 4 times +1 is 1 plus X, the oxidation state of iron, plus 6 times this -1, which is equal to the summation of the oxidation states of atoms of elements found within the given compound must be 0, which is equal to 0. Therefore X, this variable, plus is 4 minus this one is, this means 6 times -1 is -6, it's equal to 0. Therefore X plus 4 minus 6 means 4 minus 6, it is -2 remains with -2. Therefore X minus 2 is equal to 0. Then X equal to +2. This is the oxidation state of iron in a potassium ferrocyanide complex compound. Here B question number 1B is potassium dichromate compound. Therefore we should assign again potassium +1, it is obvious. Chromium we don't know, but it is going to be calculated. And oxygen is most common compounds of oxygen, the oxidation state is -2, it is obvious. Therefore 2 times +1 for potassium plus 2 times X to X plus 7 times -2. This is 7 times -2, and the summation must be equal to 0. Okay, then this one means 2 +2. 2X variable will be coming first, and because we should combine numbers with numbers, therefore 2X plus this 2 plus 2 minus this one is, that is 7 times -2 is equal to -14. Therefore 2x plus 2 minus 14 means this is -12. Therefore 2x minus 12 is equal to 0, and 2x equal to +12. Therefore dividing by 2 both sides, over 2, X remains with +6. This is the oxidation state of chromium, which is +6. Under question number 1C, this is chloroplatinic acid. Therefore we are required to calculate the oxidation state of platinum in this compound. Therefore we'll assign X for unknown oxidation states, that is for platinum, and hydrogen is obvious, +1, 2 times +1, this becomes 2, +2, and platinum X plus X, and +6 times -1. The oxidation state of chlorine is -1. Therefore it will be assigned like this ones. Okay, then the variable comes first and the numbers will be collected together. That's because like terms will be add up in the same direction. Therefore X plus 2 minus 6 times this one means -6. 2 minus 6 means -4. Therefore X minus 4 is equal to 0. Therefore X equal to +4. X equal to +4. That means this one is X plus 2 minus 6 means -4. This one's X minus 4, which is equal to 0, and 4 is taken away after equal sign in your linear equation form of calculation. Therefore, X equal to positive 4. This is oxidation state of platinum in chloroplatinic acid. This exercise 1.5 number 1D. This is just writing this the sodium tetrathionate compound. Therefore, the oxidation number of sulfur is needed to be calculated in this compound. The oxidation number of sodium is +1 and sulfur is unknown. Oxygen is obvious, it is common type of oxide compound, therefore -2. And the summation of this one plus this one plus this one, all the oxidation number sum up to give 0 because it is compound. The summation of all the atoms oxidation number in a given compound must be 0. Okay, therefore here 2 times +1, +2 plus 4 times 6, 4x plus 6 times -2. The sum must be 0. That is. Okay, then 4x plus this 2 minus this 1 times 1, -12. -12 means -12, which is equal to 0. Then 2 minus 12 means -10. 4x equal to -10 becomes +10 after equal. This is the way how can you solve for the oxidation state of this sulfur. And to eliminate number 4, divide both sides by 4. S is equal to by 2, 2 by 2, 5. So it becomes +5/2. This is the oxidation number of sulfur in this compound. And E is yes, this is radical, okay, has -2 charge. Therefore, sulfur oxidation number is needed to be calculated here again. Therefore, 2 times x plus 8 times -2. -2 is the oxidation number of each oxygen, which is equal to the charge of the ion is -2, which is equal to -2. Okay. Therefore, 2x minus 16 is equal to -2. 2x equal to becomes +16 minus 2. 2x is equal to +14 because 16 minus 2, 14. To find the value of x over to both sides, x equal to +7. This is oxidation of sulfur in this radical. Okay, when you come to D, question number 1D, not D, but F. Sorry. When you come to F, this is a type of radical. Okay, then oxidation number of sulfur is required. X here +1. Oxygen, each oxygen -2, and the charge on the ion is -2. Therefore, 2 times +1 means 2 plus 2 times x for phosphorus, 2x plus 7 times -2 is equal to the charge on the ion is -2. Therefore, the variable in this coefficient should become down first, 2x and then plus 2, and this 1 times 1 is -14 is equal to -2. Okay, now 2 minus 14 means -12. Therefore, 2x is equal to -12 becomes +12. Minus 2 after equal sign becomes +12, and then -2 will be added, which is -2, and 2x equal to 12 minus 2 means 10. It is positive over 2, or to find the value of x equal to, this is 10 over 2 means +5. This is the oxidation state of phosphorus and this radical. Okay. Oxidation state of sulfur in sulfuric acid is required. It is obvious x, but here it is obvious 1, it is obvious -2. That is the oxidation number of hydrogen in most of, except per hydride in hydride compounds, it is becoming -1. But in other compounds, the oxidation state of hydrogen is +1. Therefore, 2 times +1 means 2, +2, plus this is 1, subscript of sulfur is 1, 1 times x is x, plus 4 times -1 is the oxidation number of oxygen, and the summation must be 0. Now x plus these 2 minus 4 times -2, 8 is equal to 0. Then x equal to 2 minus 8 means -6. -6 becomes +6 when coming out of equal sign. It becomes positive. Therefore, the oxidation state of sulfur in sulfuric acid is +6. Okay. When we come to the next question, this is chloroauric acid. Therefore, the oxidation number of this gold is required. This is hydrogen, obvious. Chlorine is also obvious, -1 in this compound. Therefore, this is +1, +1, plus x, plus 4 times -1. This is 4 times -1 for chlorine. The summation must be 0. Here 1 and this is -4. That means x plus 1 minus 4 is equal to x equal to 1 minus 4 means -3. -3, 0 minus -3 becomes plus after equal. Therefore, x is equal to +3. This is the oxidation number of gold in chloroauric acid. The oxidation number of sulfur in iron 3 sulfate is required. Therefore, here the iron is oxidation number is 3 because this number 3 implies the oxidation state of this iron. Therefore, sulfur is less known, and oxygen -2 for each oxygen atom. Therefore, what is the oxidation state of sulfur in iron 3 sulfate? Okay, here now 2 times +3, 2 times 3, 6, plus here 1, but multiplying these subscripts, these inside values of subscripts, 3 times 1, 3, 3 times x, 3x, plus 3 times 4, 12 times negative 2, which is equal to 0. Okay, here 6 plus 3x minus 24 is equal to 0. Then 3x plus 6 minus 24 is equal to 0. Okay, then 3x minus 1 minus 1 means 18 is equal to 0. 3x is equal to positive 18. Find the value of x over 3 both sides. This becomes 6, positive 6. Therefore, the oxidation number of sulfur in iron sulfate is 6. This is about question number 1. Okay. Question number 2 of exercise 1.5 says A compared to plus charged particle plus 2 electrons gives copper metal, which is a charged particle. Therefore, a decrease in oxidation number from plus 2 to 0 means reaction. It is reaction. When it comes to B, potassium from 0 charged particle or atomic form goes to potassium plus 1 charge plus 1 electron. That means oxidation number increased from 0 to plus 1. Therefore, it is oxidation reaction, because an increase in oxidation number is oxidation reaction. C, oxygen from 0 oxidation state added by 2 electrons becomes oxide ion in the product. That is O2 minus, which means addition of electron is reaction for the case of C. When you come to D, as you can see, this is S minus charged goes to S0 charged particle, which means a decrease in an increase in oxidation number from negative 2 to 0. If you just assign the number line, it is increasing negative to 0. Therefore, an increase in oxidation number is oxidation reaction, which yields 2 electrons on the product side. Okay. When it comes to E, this is iron 2 plus charged particle goes to iron 3 plus charged particle plus 1 electron. This is also an increase in oxidation number from positive 2 to positive 3. Therefore, an increase in oxidation number is oxidation reaction. The F is nitrogen from 0 oxidation state added by 3 electrons, as gives nitrogen minus 3 charged particle, which means addition of electron is reduction reaction, or it is a decrease in oxidation number from 0 to negative 3. A decrease in oxidation number is also reduction reaction.